Hello, everybody. It's great to be here one more time today. My name is Gary Fowler. I'm the CEO, president, founder of GST, Get You Done Venture Studios, a premier AI and quantum venture studio located in the heart of Silicon Valley. I'm a 17-time serial entrepreneur with several unicorns under the belt. I was on the original management team at Click Software, which was sold to Salesforce for $1.35 billion. Also, Eva.ai, an AI HR tech company I co-founded with Dr. David Yang. We believe at GST that intellectual capacity is evenly spread, but opportunities are not. Today in GST, we have 185 companies representing 73 countries around the world. So today on GST Presents Top Global Startups, I'm going to bring you a very, very interesting company. Joining us today is Jue Wang, who's a co-founder and CEO of Stealth Automotive technology startup and a builder with over 15 years of hands-on experience developing chassis systems across some of the most complex vehicle platforms in the world. From legacy automotive giants to early stage EV startups, he has lived the evolution of mobility firsthand, and now he's rethinking the very foundation of how vehicles are built for the AV and EV era. Today, we're going to dive into the invisible chassis, redefining vehicle architecture for the AV EV era. A conversation on modularity, software-defined vehicles, autonomy, scalability, and the hidden layer that can unlock the next trillion-dollar company. So with that, I'd like to bring him on board. All right, so tell us a little bit about your background. What made you decide to get so deep with chassis?
Okay, thanks, Gary. Thanks all the audience online for joining this event. Very happy to be here. So I started with my career in Detroit, Michigan, working for one of the biggest, automotive chassis technology supplier, working for one of the biggest program like F-150 and the GM SUVs. Uh, I gathered very valuable experiences and technology knowledges, and then I decided to go to California to start building a chassis system first from scratch, um, and I did a couple of them, and then in those EV startup, I grew and learned not just on the technology side, also on the automotive business side, especially with with my last employer, and they're called Harbinger Motors. They are like making the last. They're making the future electric step vans and hybrid RVs, and the co-founder, they are also employee number 18 there, and I was part of the team and watched the company grow, and just learn the business side of automotive in the background, and the co-founder really inspired me, and I see there was a big problem in the auto industry, that's lacking of a key suppliers like that we can do. So I decided to pull the trigger. With all the lessons learned, I started my own company. Um, you
How
know,
was that when you went down through? You had a job, you were working. How was it to to go dive across the chasm? Were you afraid? How did it feel making that choice?
uh, I think I was more excited and assured than afraid, um, because I know this thing is going to happen. Working, being in the industry for so long, and I think part of the reason, also that's my backstory of starting this business. When I was working for this startup, I reach out to all the chassis supplier who can sign up to help us for innovation. I couldn't find one that is able to sign up. Um, we we ended up to find somebody overseas, and they are really don't have a full experiences with it, but they're like, they have the spirit and they like what we're doing. And so it was kind of a very a long and exciting journey in the past few years. And then I see there's an opportunity opening. Why can't I just have something that can fill this market gap. All this EV and AV company that's starting, they need a company who can move fast with them to provide the technology they're looking for. But I'm not saying that the the legacy company that they cannot provide such a thing, but they have their own focus by they need to um, make more revenue, make more profit. They have a big company structure. They want to sign up with a big volume product. So they are really leaving the smaller emerging automakers behind. Um, and that's another reason I see there's an opportunity that like a big opportunity that we should somebody in this field should be able to fill.
So, you spent 15 years deep in chassis engineering. What originally pulled you back into this layer of the vehicle stack? And then the other question is, you've worked across both legacy OEMs and startups. What's the biggest mindset shift between those worlds?
And that's a great question. Let me answer your first one. So I I don't know. I always like mechanical stuff. I grew up in Beijing, China. In the 1990s, there we don't have a car in my family, and every time I take a bus, we have to take a bus to go places. I always stand behind the driver to watch him driving. So
Wow.
many years.
Well, you were addicted, huh?
Yeah, I was addicted. I was just like every single time I wouldn't see it. I just have to watch the bus driver driving. He's just so fascinated that he can operate a big box and taking people to everywhere. And I started doing things, I think, when I was a 3 year old, because my mom had to take me to, to learn English outside of my regular school curriculum.
Did you like it or not?
I really enjoyed it. I think that, yeah, the English learning from early days, and then the combination of me watching the bus driver driving and
Now, I got a question for you. What was your first car?
it was actually when I moved to US, it was a 1996 Ford Taurus.
And did you like it?
uh, it was a car. It was a like $1,800 car.
Uh-huh.
Um, it gave me two places, and I think I blew the motor. I went to Iowa State for for school, and then one weekend I traveled to Minnesota, and on the way back, was just driving. I think there was a problem with the transmission on that car. It doesn't have the fourth gear, which is the toughest gear, and then
It didn't
yeah,
have a fourth gear?
it had, but it was broken. It wouldn't shift into the highest gear. I didn't know
Was it
that.
automatic or manual?
It was automatic.
Wow. So how did you do that on a trip to Minnesota?
Yeah, it was the engine was revved really high, over 5,000 RPM. And then when I go back after I got off the freeway, I blew the motor.
Well, you're lucky.
Yeah, I was lucky. I didn't I didn't broken on side of the road on the freeway. I got broken back in town. So
Somebody was looking over your shoulder, watching you and helping.
yeah. So I was really lucky. But yeah, back back to that story. I actually started driving a stick shift. My first time driving a car was when I was 12 year old, and my cousin had a came had they had a car, and we live in a enclosed community in China where the cop doesn't it's not in the community. It's pretty big. We have our own private road. So I was able to drive a stick shift car when I was 12.
At
The first,
12?
huh?
At 12, you were driving a car?
Yeah.
You didn't have any accidents or anything, did you?
No. I stalled once, and then I was able to move the car, driving up to like a 30, 40
That's unbelievable.
kilometers per hour.
Now, did you pick up your friends and take them out and say, hey, come along and we'll tell
No. My cousin was bold enough to help me drive, and then when we go back, and my cousin told my mom was pissed.
I bet you was.
Yeah.
That's unbelievable.
But yeah, that was my one of my experience in the early days that set me interest in mechanical engineering. I was always loved.
Where'd you go to school? Did you go here in the U.S. or did you go in China?
I went to US. I started college in the US. I moved to the US when I was 18. But before that, I was in China.
And where'd you go to school?
In college, Iowa State University.
Now, how was that after coming from
Y-
China, in the middle of nowhere? Did you learn about wrestling? Did they talk about wrestling a lot?
No, I didn't learn wrestling, but I did learn how to cross the crosswalk in the United States, especially in Midwest, because in China we got like in Beijing there's like 80 million people I think when I left in 2008, and I think the state of Iowa was either 3 or 6 million people.
How was it living out there? Like culturally, what did it change? Because they're kind of laid back and they're kind of like
Y-
farmers and they like
Yes,
wrestling and football, especially wrestling, right? Wrestling is like people talk about well, Dan Gable, I remember from the old days, right? They would like it was like their hero. So how was the adjustment culturally went to go to Iowa?
I think I just had a very big culture shock, and people are so nice, like they talk to you, and then when you cross the street, when you get on the crosswalk, all the cars stopped for you, and I was
Yeah.
like, I feel so embarrassed at the beginning. I don't know what to do. Like nobody in Beijing is gonna do that for you.
What would they do in Beijing if you were crossing the street like that?
You have to wait for the cars to for them to pass, and you're gonna run when there's like a there's like a time interval. But I think things has getting better now. There's more pedestrian light and it's more regulated.
Now, how about I don't know about how it was in Iowa. I'd been there a couple of times to Davenport, but
Okay.
I know when I lived in Kansas, they really could eat food. Like they really like to eat. Like a lunch, I'll never forget it. A guy took me out to lunch, and he said, "You want? They have a lunch special." And I said, "What do they have?" And he said, "A rack of ribs." And I said, "A rack of ribs, yeah." And he said, "The French fries." And so we get this. It was dirt cheap, and this was enough. I think like three people could have eaten it, and we got one for each of us. And he finished his. I couldn't believe it. I've never seen that much food in my life. And they like to go hunting and pheasant hunting and all that kind of stuff. It was interesting. It was even for me living in the U.S. It was culturally different. It was people were just really nice. So I mean, incredibly nice actually.
Right, and I really enjoyed living there and studying for 4 years. I think with a smaller place, there's not a lot of noise, and we can focus on our study. And I
There's not a lot
also
of distractions either, right?
right. And I also joined the Formula SAE, where like we build a race car in college, and then we go for competition.
What was SAE? It was
It's called Formula SAE. It's a school project, school club race car, uh,
was it fun?
competition. Hmm?
Was it fun?
Oh, it was a lot of fun, and that's like the first time before my career I started to really involve in hands-on building a car. Um, you know, going to competition to put something from the computer to make it into the real product. And I think that's also the reason why I could be able to get an intern in one of the biggest automotive companies in the world. So so I think very glad I had that experiences, and yeah.
No, it's invaluable and I lived over in Russia myself for a while, so I actually moved to
Oh,
Russia for 12 years just to
okay.
see what it was like. And the um, the one thing that happened with me is you look at the similarities in people, not the differences, and you're okay then, because it's always interesting. There's always something that's, I would fly to Siberia and people wouldn't. People from Moscow had never been to Siberia, and I was out in Siberia in the taiga in the woods, and it was just interesting. And other people didn't do it or go to Vladivostok or places like that, and they wouldn't do it. And I saw things that were just amazing, actually.
Right. You're absolutely right. I think there's people from I think people from Iowa and from Michigan and from California. They're like with the past three states I've lived in, people are actually um, their thought process are different, like their habits are different, and but they they always want to like be nice to you.
No, and that's important, right? And if you're
Right.
nice to them and curious and kind, the same thing happens back. Let's talk about this. You talk about an invisible chassis. What is an invisible chassis? I mean, does that exist or not? How is it different from traditional chassis architectures
I,
used by companies like Ford or Toyota?
I think invisible chassis is really meaning like the general consumer doesn't really think about it when they are driving the car. Uh, I think everything, or the general consumer, they think a car as a whole, and but chassis, in my mind, is one of the most important part of the car that's underneath, and that nobody
Yeah,
really
but most
cares
people
about.
don't think about it. But let me tell you, if there's a problem, you could die. You know what I
Right,
mean?
right, exactly.
People don't
So,
understand like the kind of issues I've had. I don't know, 50 cars or so over the my lifetime, and I've had chassis problems, and nothing good happens.
yeah, right. So I think there's a lot of a company now is making ADAS system for autonomous driving, uh, doing the sensing, uh, doing the algorithm, making the controller much greater. To me, like let's just make a car like a human for analogy. I think those are our eyes and the ears
Hmm.
and the brains for sensing. But I think for the past 5 to 10 years with all the automotive startup, nobody has really focused on building the muscle to be stronger. I
Yeah.
think the chassis part will be the muscle to human beings and the bone structures that can really support your brain and eyes and what they want the whole body, whole car to do as a whole. So um, I think, yeah, to having a startup focusing on to develop a future muscle of the car, like
Hmm.
getting it smarter and stronger to be able to capable to support the so advanced sensing.
Well, I mean, the other thing is the batteries are really heavy, right? So if you don't
Right,
have a chassis, people don't get how much more weight those batteries have. And with autonomy sensors and compute, they become critical, right?
right,
And how does a chassis have a synergistic relationship to be able to support the changes, right? Like you said, the sensors, the autonomy, and the compute, because those three things are critically important in order to have a hyper intelligent car.
right. So I'll just make an example from my braking system and steering system. Before, like they are really they're based on hydraulic. They need a hydraulic to operate, and they're now really integrated to communicate with all those advanced communication interfaces with the self-driving portal, and the industry has spending quite a lot of time and thinking the way how to innovate it, but there always had hardware limitations from the hydraulics on both steering and the braking system. I think to be able to, uh, in order to really accommodate and making the autonomous driving to be into the next stage, the foundation of the car really need to evolve. So I think to removing the fluid to make the system to be more software defined, you know, that's a key. Um, that's a key goal to be able to move the whole automotive AV or EV to the next step.
So, do you see the chassis becoming more like a platform operating system for mobility?
Uh, yes, I think so. So I think um, there are, we probably don't know, but there are actually 20 to 30 computers for each subsystem in a car. That's like how many brains in a body. Each brain controls a different part of the body.
And you hope
So
you don't have a problem. I had a problem with my CPU in my one of my cars, and man, talk about an issue.
yeah,
It was like it was over the top. We couldn't figure it
right.
out. We had to finally replace the computer in the car. I didn't even know the computers. I didn't realize how sophisticated those computers are. Incredibly sophisticated now.
Right, right. No, no, I think the way it's moving forward, we want to, integrate more, uh, you know, integrated from different computer into one to control more stuff, like a steering and braking system and suspension system. We can integrate maybe into one controller, have one uh, one brain to control all three systems. That will be more coordinated, more efficient.
Maybe having some redundancy just in case there's a problem, right?
Right, right, exactly. Now something happened, like say,
Driving down the turnpike or route, you're going down to one of the highways, 101 in Silicon Valley, and something happened, nothing good's going to happen, right?
right,
Especially,
right. Now we can have a redundant, like say my steering failed. My steering, I cannot steer the car. Now I can actually use the brake to steer the vehicle.
actually had that happen, actually.
Oh yeah,
Yeah, I
that's
was driving down 101 and I was in my car, and it just shut off. What happened is when it was a relatively new car, a wire grounded to the body of the car and shut
oh,
off the electrical system. And so I'm driving. Once that shut, the power steering, everything, and I'm like, oh, this is bad because
that's
it's
really
really,
bad.
really hard to turn a car when it doesn't have any power assisted steering, right? Power steering.
Right, right.
And I thought, this is it. I'm dead because there was no place to. And I was like you. I was really lucky because I came upon a part to turn off where there was a little area between the road and the access road, and I got off. I was so lucky. I was scared to death. Actually, I thought, oh, this is. I mean, I could nothing. Everything died on the whole car.
Yeah, I'm glad that you're okay. You, yeah, I think the chassis system, like most of, when they're fine, 99% of the time they're okay. But when they failure is going to be a catastrophic, and that's like one of the reasons I founded the company. I want to make sure the chassis system in the future is very very robust and have enough redundancy for the cars. So even though even when part of some components has failed, we'll still be able to control the car and make it into the safe state. And yeah,
So, how does modularity change manufacturing economics at scale? And how fast do you think this is going to? How fast do you think companies like yours are going to come into the market because they understand they're not doing a good job?
so I think in the conventional business model, like just for braking system, the conventional brake system, you have a 6 to 7 8 different component, and the car manufacturers has to deal with them, like with different companies and pay
Yeah,
development
all the
fees.
time because they get a good deal on some brakes and they buy the brakes from X distributor, right? They're
Right,
all the time, and so you don't know if you're getting something great or you're getting something mediocre.
right, and not just yeah, and on top of that, like they have to like the car manufacturers spend like tremendous amount of hours by doing system sizing to making sure the parts from different supplier, your pedal, your actuation, your wheel end calipers are working with each other. And but now when we like putting all these like things into a modular and apply form, the car manufacturer can just deal with one supplier.
Well, tell me about modularity because I think, especially with electric vehicles, you buy a Tesla and you got the battery in the car, and by the time you sell it, it's 50% or 60%. I'm just making it up of
Mhm.
what the original battery had in terms of life. Being able to have modularity with that, right? So the batteries where you can pull them in and out. Right now, it costs a fortune, like $20,000 or so. from my understanding, to put new batteries in the car. Wouldn't it be nice to be able to have modular everything so you could keep the car longer and upgrade it, over time.
Right, right. I think that's the general idea that with the less hardware architecture, simpler hardware architecture of the system, uh, we are able to make this the subsystem more modularity. And like for example, the braking system, we don't need to bleed it anymore. When you do the service, you just swap the parts and go. And it really reduced the service time and service costs for the end consumer. The dealer might not like it, but that's that's where the technology and industry is heading to.
No, I agree. I agree,
Yeah,
and it's got to happen because the cost of the cars are too much, and the platform basically you got to, your engine goes bad. I just put an engine in one of my cars. I love my car. I have a Honda Element,
okay,
and it was a $9,000 to put an engine in the car, and I love the car, but shouldn't it be a lot easier? And instead of spending 2 weeks in a dealership trying to get the thing figured out, and with the electric vehicles, it's incredible because we spend so much money for them, but they should be modular and upgradable because the motors don't go bad. It's the batteries, right, for the most part.
right, right,
And
right,
so, if you lose range, I know with my electric vehicles that I have here, range does go down over time. It goes down a lot sometimes. And, I get range anxiety. If I've had a electric vehicle too long, I start to get nervous because I can tell it's going down, you know?
right, right.
And then I think about, okay, I want to upgrade it, but if it's $20,000 to upgrade it, it's worth just trading it in. But it shouldn't be like that. We should just have the ability to swap a battery in and out, right?
Right. Yeah. I think to innovate a chassis. Sorry, I keep going back to the chassis system, but this is all related.
Hmm.
So one of the big problem we are solving right now, if we got rid of the physical connections from the chassis system, like for example the fluid line and the steering fluid line, we got more room for design the package, the battery package so well, and for, so the engineering can be more creative, to put in to make the serviceability more better, so the service dealer can take out the battery and put a battery pack more quicker and faster,
Well,
less
that's fine,
cost.
and we don't do it, right? It's not that we
Yeah,
don't we don't make it easy for a reason because they want to sell you another car.
yeah. When we designed, the EV startup from with my past couple experiences, we
Mhm.
spent almost 3 months. The battery team and chassis team who designed the brake line, they fight each other. And the battery team tells chassis guy, you need to move this brake line from my battery because we need to have a serviceability. When we take out the battery, your brake line cannot be in the way. And the brake engineer will spend like 2 to 3 months just
No,
having.
it's crazy, right?
Right, right. So I think this is a problem that we're also solving. Like the consumer doesn't see, but the engineering's, they're really trying really hard to make the car to be more better serviceable, more efficient, and user friendly for the end consumer.
So you have a question. So they want to know, do you see a future where roadside service might be offered remotely, based on the way these chassis are changing, the cars are changing. And the second one, if a car's computer operations break down, could they be able to serve the thing remotely? Or when you get to a point where not only chassis can be taken out, but the car can be fixed remotely. You don't even have to take it into the shop because it's with electric vehicles, you got updates, etc. Or is it too risky with security? So their question is, if we had those capabilities to be able to access your car, is it going to be that hacker gets in there and shuts it off and you're going down the turnpike in Pennsylvania?
I think that's a very good question. And thank you, Karen, for asking that. I think the short answer is yes. For anything electrically related, can be fixed remotely. Uh, and some of the cars can even download the software online. We call the OTA, over the air update, and Tesla does that currently. Uh,
Hmm.
so when we develop the vehicle, develop the system, there's a very strict either SAE, Society of Automotive Engineering, or ISO international standard that we need to comply. One of them is a functional safety, and the other one is a cybersecurity. So we need to, each company will have their proprietary code and to follow that these standards, to making sure that the cars are robust enough. Uh, Even with, with a communication protocol between each brains, we have such a you know safety protocol implemented. But very good question.
Yeah, thanks, Karen. That's great. Listen, we're coming to the top of the show. So, your closing thoughts, how do people get a hold of you? And if you want to stay online after we're done with the show, we can speak for a few minutes.
Okay, awesome.
So, closing thoughts, and what should they be looking at? And then, how do people get a hold of you?
Okay, so I think the automotive world, the AV and AV, EV, or whatever energy source the vehicle is going to use, nuclear, you name it. But the foundation of the vehicle needs to be evolved, and we are on a mission to to make a chassis system for automakers so that the consumer can really have a better car to be driven on the to drive on the road. Um, so and I guess you can reach me from LinkedIn. Search my name, and I'm always here.
No, it's great. Thanks for taking time out of your busy schedule to join us today. For
Thanks
all
for
of you
having
out
me.
there, we're at 1,700 podcasts, millions of views, and thanks to all of you, and thanks to you for coming on the show today, you and talking to the group, because these are the kind of things we got to think about, right? People don't think about, the car. If we made a modular, it's going to save a lot of money. And it's going to allow us to have it a longer time. And the cars are expensive today. I don't know what the average price is exactly, but probably $45,000, $50,000, and it's a lot of money. It's a big investment. If we could protect our investment with technologies just like yours, the world's going to change, and it has to happen. We can't keep doing what we're doing now. It will not work. It's another 3 to 5 years, and we're going to get in a position where soon it'll be like buying a house. It'll be your car, and so you should be able to last 2 to 3 times as long. And we're all at some point going to have some kind of other powered vehicles. So you're doing a great job, and we really appreciate you coming on to the show. So to all of you out there, stay happy, stay safe, and stay healthy. And I'll be back to you again soon with another exciting edition of GSD Presents Top Global Startups. My name is Gary Fowler, and I'm your host. Stay happy, stay safe, and stay healthy. I'll be back to you again soon. Yeah, I'll be back as soon as we end the show.